All right. Hey, everyone. Let's get the show on the road. So my name's Tom.
And I'm Alex.
And this is the story of how we moved hundreds of MySQL databases into Kubernetes. So what is HubSpot? We're a marketing, sales, and services software platform based in Cambridge, Massachusetts. The HubSpot app is actually thousands of different microservices built and deployed hundreds of times a day by many small autonomous teams. Our computing footprint is about 3,000 VMs in both AWS and GCP. And before we get to the good stuff, I want to turn the clock back to 2013 for a minute. Life as a developer at HubSpot was kind of hard. We had a clunky CI pipeline that was basically just one Jenkins instance that we affectionately referred to as Big J that was constantly falling over. We had a flaky SSH-based deployment system with no sophistication. We had no elasticity and no automation in our infrastructure, which meant it was not uncommon to be woken up at 3 a.m. in the morning because someone's nightly job was taking down your web service, or one of the EC2 instances that powered your web app went impaired and you had to do something to replace it. We'd been looking at Apache Mesos at the time, and we seriously considered evaluating it in the fall of 2013. The thing about Mesos that's different from Kubernetes is that it only provides the primitives for running your apps on a cluster of resources. Don't worry, I'm going to get to Kubernetes soon. I didn't think I'm out of MesosCon. So we surveyed the landscape. There are a bunch of different things out there for running tasks on Mesos, but we found that they were very generic and wouldn't provide a great developer experience for people working on the HubSpot product. So we did something crazy, and we made our own Mesos framework called Singularity. It's still running to this day, and it's an opinionated look at running web services, workers, and cron jobs in Mesos, tailored to the way our developers work. As far as I know, at this time, Kubernetes was just the twinkle in the eye of a few Googlers. And it ended up being a great success. We were able to save money by consolidating instances. We were able to improve reliability by automating away all those 3 a.m. wake-up calls. And we were able to improve productivity by making it easy for developers to do things that mattered most, like tailing logs or taking heap dumps or whatever. And as you can see by a younger, less stickered Tom, we bragged about it a lot. So time goes on. Being a product developer is now not so bad. You have Singularity, but what about the infrastructure? The infrastructure at HubSpot was still kind of in that 2013 world of lack of automation. Life was hard. We could have taken the route of adding stateful support to Singularity, but we really liked how Singularity just did one thing well, and we didn't want to have to reinvent a bunch of different wheels. So at that time, we kicked the tires on Kubernetes. We liked what we saw, and we decided that we would explicitly try to do our stateful workloads on Kubernetes and worry about consolidating Singularity and Kubernetes down the road. So of our infrastructure teams, data infrastructure was the first to take the plunge, and the hottest fire in that world was MySQL. We got Alex from the SQL team here to tell more.
Yeah, so in 2016, if you were a product team at HubSpot and you were spinning up a new microservice and you had some data, you had this decision tree to look at. If your data was streaming or you had to deal with user input queries, you used either Kafka or Elasticsearch. But otherwise, you were looking at MySQL or HBase, and probably just because it was more familiar to you, you used MySQL. And with so many small autonomous teams building microservices, it means we ran a lot of MySQL. And just to put numbers on it, I'm talking about roughly 450 MySQL clusters back in 2016. And a cluster here means generally 2 machines, possibly more, but like a master and some number of slaves. And the 450 clusters are 225 in QA and 225 in prod. So if you do the math there, we're talking about like at least 900 EC2 instances, but actually in reality closer to 1,000. And that's painful, right? That's expensive. And operationally, it doesn't scale, right? With more services coming up all the time, we just have a worse and worse problem. Because Amazon has a non-zero impairment rate, which means somebody on my team gets paged and you put hands on keyboard, run an Ansible play or 2 or 3 of them. So that sucks. And like I said, it's getting worse all the time because we're always spinning up new microservices. But even just to do that, right? Your team, your product team, files a JIRA, and then somebody on my team has to provision some virtual machines with a Puppet class and set some Puppet variables, and all the while, your product team is just waiting and waiting and waiting. The other axis it wasn't scaling on was the actual database itself, the query and data load. You know, with no real idea how big your service is going to become inside the HubSpot app, we would generally start you off with a smaller set of EC2 machines. And we could, again, via some Ansible plays, size you up to a larger instance size and size you up again. But at some point, you know, EC2 instance sizes are limited, right? It doesn't keep on going, and you would have to kind of graduate up to HBase, which is terrible, right? You're putting your relational data into HBase. And you have to like rewrite the whole data layer in your app. The other thing you could do is build sharding into your application, which is itself a nightmare, and really just a nightmare that you would ever just want to do once, not 1,000 times, right? We have like 1,500 microservices. So yeah, that's also a pain in the ass. So we needed something that would meet us on the operational front and the data scalability front. And we looked around. So it's end of 2016 at that point, maybe like September, October, November. And this is what we saw, right? So here's Citus and Cockroach and RDS and Galera and Vitess. That's what we saw. But we don't really want to use like Citus or Cockroach because we want to stick with MySQL, right? It's what we know. It's what we have all the operational experience with. And we weren't really comfortable with handing our infrastructure off to a third party like AWS and pay through the nose and deal with more or less glacial support turnaround. And it doesn't actually scale horizontally, right? It doesn't shard. So that's kind of a non-starter, not a good fit for HubSpot. And we knew, like Tom was saying, that the rest of our infrastructure will be moving in the Kubernetes direction. So we wanted something that would at least rhyme with Kubernetes. And so Galera, extra DB cluster, whatever, that's out. And so we landed on Vitess, and we really liked what we saw. It's MySQL based, it's open source, it's cloud native, and we really liked that it wasn't new. At that time, back in 2006, it had been deployed in production at YouTube for several years. So what's Vitess? Hopefully you got to go to one of the talks earlier this week. We've had a few really great talks, but even if you did, I want to highlight a few parts of the architecture there. Over on the right, you see it's labeled admin. It's the control plane. There's a bunch of boxes there, but the thing it doesn't say is that this VTCTLD, that's the Vitess control daemon, actually has an API that you can code to. So that's awesome. The data plane, however, consists of 2 parts. The VT-gate, which is a proxy there, and VT tablets, which are like sidecars that run next to your MySQL process. Yeah, so that's a lot of boxes, right? How do you set it all up? Well, it should run in Kubernetes, right? Well, not really. It was like designed to run in Borg, but it should run in Kubernetes. So we just got started. And we got started like anybody would, right? With Helm. But it got a little unwieldy, right? That's a lot of different Helm charts. And it didn't really give us the control that we wanted, right? I never, ever want to roll out a release and have all 500 databases, see the number is going to go up as the time goes up, all 500 databases get updated right then. That's like, right, I need canaries, I need all that kind of stuff. So around, let's say, January maybe of 2017, somebody on my team found this blog post from CoreOS introducing operators. So that, I guess, was written November 2016, but we didn't really have a need for it, didn't see it until January or so. And we fell in love. We scrapped Helm immediately and started writing an operator. And this, you know, this is like well before operator SDK, so we didn't have any of that. So we're just writing against client Go. So hopefully you've seen something about operators. It was even in one of the keynotes this morning, but just to put a pin in it here, it's an extension of the Kubernetes API with resources that you define called custom resources, and then your operator just translates those things into objects that Kubernetes knows about natively, like stateful sets and pod disruption budgets. And that was really important for us to have a translation layer made out of code that we wrote, so that we could, in fact, roll out a change across all of our databases at once, but do so in a controlled way. So yeah, I want to dive in a little bit here. We have a couple custom resources, but the main one that describes databases or key spaces in the terminology of Vitess is right there on the left. And this is abbreviated, but you can imagine the kinds of stuff that's in there. You got a name, you got a performance class that shows the size of resource limits and requests for your pod, how many replicas, and that last one there, sensitive, just to say HubSpot's public. So this one is, does the database contain data which should be considered sensitive for Sarbanes-Oxley compliance? So it's a mouthful. And our operator translates that bit of YAML into 3 different things: pod disruption budget, which Tom will talk about a little bit later, a cron job that we use for backups, and a stateful set. And yeah, the meat of that is the stateful set, and I want to dig into that. And the meat of the stateful set is the template for the containers in a pod. And you can see our pods are pretty thick. We have an init container down at the bottom. I'll work bottom up. It's called init vtroot. And all that does is initialize a fresh persistent volume, right? Set up directories and pull data in. And then we've got 3 housekeeping containers: cron, fluentd for shipping out logs, and collectd for shipping out metrics. And then the 2 kind of heavyweight containers, MySQL and vttablet. And you see, those both have a pre-stop hook, which again, Tom will talk about a little bit more later. And the vttablet pod, the vttablet container has a liveness probe and a readiness probe. So I don't have 2 hours to talk to you about all the work my team did, but I want to hit on some of the high points. We do have another custom resource that manages pools of VT gates, or describes pools of VT gates. We run several different pools that pass different options into the underlying VT gates, and we want to be able to scale those things differently. So that's that. HubSpot looked at the options for a JDBC driver, and while Vitess speaks the MySQL wire protocol, we chose to actually use the Vitess JDBC driver, which is really just a thin wrapper over gRPC. Mostly because the rest of our infrastructure is going to go in the gRPC direction. And if you remember all the little boxes on the architecture diagram, well, all those things talk to each other via gRPC. And so to secure it, we had to make a little infrastructure for mutual TLS. And we built out one of those backed by HashiCorp's Vault. And it includes security all the way to the microservice, where we've got short-lived TLS certificates. Another bit of work we did was to integrate Orchestrator into our installation. If you're not familiar with it, Orchestrator is the HA solution for MySQL out of GitHub. Great piece of software. And finally, as you might expect, Vitess grew up at YouTube, but HubSpot's corpus of queries is different from the corpus of queries at YouTube. So we actually had to augment the grammar of the SQL dialect of Vitess. And we did that in a couple parts. First step was to basically pull the parser out of Vitess into a thing called vtparse and just shove all the general logs through it just to see what was going to fail. And then once we had an idea about that, we could hit yak and actually change things up. So that was pretty interesting. The other thing I'd like to talk about is how we did the migration itself, just because it comes up all the time in the Vitess Slack channel. It was really important for us when we were preparing for it to do some work in our backend, the framework, libraries, stuff like that, so that we could make transition one database at a time. This diagram's pretty simple. It's just got one app to one database. In general, we've got like a N to M setup, but just to make the diagram live withable, I'll just show this one-to-one thing. And here, so it's an app, so that's a microservice, which could actually be like multiple instances of the same microservice. And then that's two EC2 hosts on the bottom, one replicating from the other. So that's the initial state. The next step was to stand up a VT gate, and that happens to be in Kubernetes, but that's neither here nor there for this. And at this point, we're not using it. It's just running. And then we start up the VT tablet. That's the sidecar right there on the EC2 host. And then we create a key space object corresponding to that database. And then our operator in Kubernetes starts up 3 pods for that database, replicating from the MySQLs that are not running in Kubernetes. And then we built a little flag that we could flip on and off for the app to send its traffic through Vitess or not. And once we had figured out that all the bugs were figured out for this particular app's queries and Vitess, we could proceed with I don't know what you want to call it, a switchover, a master-slave swap. Vitess calls it a reparent, where we made one of the MySQLs running in Kubernetes the master for the replication topology. And then, finally, once we were satisfied everything was working properly, we could shut down the EC2 hosts and start saving money. It's important to note this whole thing has 0 downtime, right? At no point were we read-only, at no point were we totally down. The data was always there in the MySQL, so if we needed to switch back to an earlier phase and not use Vitess for something, it was all there, all just worked. It's pretty important that we had to, that we smoothed everything out, because we had to do this hundreds of times, right? Like hundreds and hundreds of times. But while my team was getting Vitess to work for HubSpot, Tom's team was getting Kubernetes to work for Vitess. So here's Tom with some of the issues that his team faced.
Thanks, Alex. So one of the early traps that we fell into was neglecting to account for how node maintenance could affect our services. We figured that if a pod could handle a deployment, a scale, maybe a surprise termination, we were golden. And then we learned the hard way about pod evictions when we replaced too many nodes at once during a Kubernetes upgrade, and the scheduler had no concept of that all pods in a stateful set being evicted is problematic, so it went ahead and did it, and we experienced downtime. So the fix here was easy. As Alex said earlier, we updated the operator to ensure that every stateful set had a corresponding pod disruption budget. That allows you to define the rate at which pods are evicted. If there's one thing I tattoo on my arm, though, it would be that deletion is not eviction. This bit us as recently as last week when we ran a kube control delete pod and forgot that that hits the pod deletion API, not the pod eviction API. The pod deletion API is not subject to pod disruption budgets, so we had a little surprise there. If it can happen to us, it can happen to you. Kubernetes makes it really easy to inject config into your pods through secrets and config maps. But we run 7 different Kubernetes clusters across different environments and different regions. So a given secret in a Kubernetes cluster may not be the single source of truth. Instead, what we do is we store all of our secrets in one centralized vault cluster. And then we created an operator that will sync these secrets into Kubernetes. The secret updater operator defines a custom resource that we call a secret template that lets you define a secret that references values in Vault. And it will make sure that the generated secret is always up to date with Vault. The other benefit here is that if we experience any downtime with Vault, it's no problem at all. So because we're running things that aren't necessarily Kubernetes native, like MySQL, we have to write out a lot of configuration files in our pods. And one way you could do that is by having config maps, but all of our MySQL pods are slightly different. And that would result in a dizzying number of config maps, and we don't want to have to manage all that. So instead, we built a tool that will take care of it for us. HS render template is a Python script that we build into our base Docker image. And all it does is it accepts a Jinja template and any combination of downward API values, node metadata, YAML files, environment variables, and writes out the result to another file. This is typically something that we do in the entry point of our Docker images. So, as you know, stateful services in Kubernetes means that you have to pay close attention to pod lifecycle. As Alex mentioned earlier, we used pre-stop hooks in order to terminate pods gracefully, and we do it in 2 different locations. For the VT tablet container, we have a pre-stop hook that checks to see, is this pod a master? And if it is, before we shut that down, do a planned reparent, or the Vitess term for a master-slave swap, to make it a replica. Once the pod is a replica, it's safe to shut down the tablet container. Because the tablet is proxying these queries to the MySQL database, we also got to make sure that the MySQL container only terminates after the tablet container. Otherwise, there could be a dip in service. So you have another pre-stop hook that simply just polls to see, is the tablet still running? If it's still running, let's not shut down MySQL yet. Does this look familiar to anyone? This is what happens when you're an idiot and run out of resources in your cluster. So we hit this early on. We would have people testing things and be like, hey, my pod's pending. Like, what does that mean? And we'd have to dig through, and we'd assume like something was broken, and then finally it just turned out no, we didn't have enough nodes. So outside of Kubernetes, we have a lot of custom solutions to handle auto scaling for things like Mesos. And initially we were going to do the same, but then we found the cluster autoscaler project for Kubernetes, which does a much better job than we could ever do because it bakes the Kubernetes scheduler logic into it. One other really cool outcome from this is that we're able to do things like only spin up expensive GPU-enabled nodes only when our ML team is actually like training models or something. So we're able to give them what they need without wasting a lot of money. So we format our MySQL volumes with XFS instead of extension 4 for improved performance. And Kubernetes makes that really easy with storage classes. Except the version that we were running when we first started did not support FS type for dynamically provisioned volumes. This was later fixed in 1.8, but we had to do some MacGyvering to get around that in the meantime. And the way we did that is we noticed that when kubelet is mounting a volume, it's shelling out to make FS and mount in order to set everything up. So we injected a wrapper onto the kubelet path that, it's insane. When you're mounting a volume, it calls out to AWS to see what are the tags on this EBS volume so that we can figure out the name of the PVC. Once we knew the PVC, we called that to Kubernetes to figure out what the storage class was. And once we knew the storage class, we knew what we actually needed the file system to be, and we called the right scripts. So this one's a mouthful. We needed native networking performance and the ability for services outside of Kubernetes to easily reach pods inside Kubernetes. So overlay networks like Flannel were out. Instead, we opted for using the VPC's network space directly. Nowadays, you can do that pretty easily with EKS or Lyft's IPVLAN plugin, but those weren't options at the time. What we ended up doing was using the default Docker bridge and some fancy routes and some complicated IP tables rules to directly bridge pods to our EC2 network. This was really cool, but it came at a price. Because we were beholden to the default allocation strategy that Docker uses for IP addresses, we were noticing that it was going lowest first, which is fine, except for when you're rolling all the pods. So we would see these issues where a MySQL pod would be torn down, a new one would come up and take its IP, and there would be a period of time where that wasn't fully propagated throughout the cluster, so that apps would be trying to reach a pod thinking it's one thing, but it really being the other. It wasn't that bad for MySQL, but it was truly bad for Redis, which at one point we actually had 2 clusters join each other, which was bonkers. The way we were able to work around this was by creating a CNI plugin for kubelet and an IPAM plugin for Docker that effectively allowed us to allocate IP addresses in a first in, first out order, which bought us more time before reuse. So our Vitess backup strategy involved stopping MySQL on an up-to-date replica. But we didn't want to sacrifice one of the replica pods that we had for this. So instead, we used a cron job to create an ephemeral pod whose sole purpose was just for backups. So it would restore from the last successful backup, catch up on replication, take the backup, and then shut down. Like anything else that needs storage, and the easiest solution was to simply create a persistent volume like all the others. The problem there is that these pods don't last very long, whereas the PV sticks around forever unless you intervene. So that's, the volume is idle and money is wasted. You may think that the solution here is empty dir, and you'd be wrong, because although that is some improvement, you still have to provision your Kubernetes nodes for your biggest database in terms of space and I/O bandwidth. The solution that we arrived with, that is the best of both worlds, is using the Flex Volume plugin. We created our own Scratch EBS Flex Volume plugin that our backup pods use that creates an EBS volume when the pod starts up and destroys it when it shuts down. So when there's no backup running, there's no volume, no waste. StatefulSet rollouts are kind of a crapshoot because Kubernetes had no concept, that one of these pods was a master or, more important, maybe not more important, but, needed more care than some of the other pods. So we could get into situations like this where we're rolling out a change and we incur 3 different failovers. Of course, the best case scenario would be terminate the master last. There's one failover, but what can you do? What we ended up doing was taking this rollout logic out of Kubernetes and putting it into our operator by making changes to our stateful sets with the delete propagation orphan setting on. What that allowed us to do is make the stateful set change, but not trigger a rolling restart of the pods. And then the operator, knowing which one is the master and which one are the replicas, would restart the replicas first. To recap, Alex is going to hop back over to talk about lessons learned.
So I think the main theme for lessons learned for us is that this was a transplant operation. Vitess grew up at YouTube. HubSpot has different needs, different corpus of queries, but also a different environment. We're installing it in Kubernetes. At YouTube, it runs in Borg. We run Zookeeper. YouTube has whatever it is, Chubby, and down the line. DNS is different from BNS. All that stuff. So I want to say that we've worked through most of this stuff by now, but if you're considering using Vitess in your organization, it might be useful to remember where it came from. But with all that hard work from my team and Tom's team, I just want to brag a little bit about what we got to do. So we have a real database as a service, right? No more filing a Jira and waiting. Any engineer can go to a page, fill out a simple form, hit create, and then 5 minutes later, their team gets a little Slack notification saying hey, your database is ready. And I want to be clear, this form is dead simple. It posts JSON into Kubernetes. The watch in our operator gets a little tickle and makes pods. And so we do nothing. We get a Slack notification as well. It says hey, somebody's making a database.
And we pat ourselves on the back every time.
Yeah. High fives all around every time. We have trivial read scaling, right? If you want to add another pod to the database, it's a simple kubectl edit, and it just happens. We take advantage of the Kubernetes scheduler's bin packing in a pretty neat way. Because we're saving money, we actually then run 3 pods for every database instead of just 2 EC2 hosts. And that lets us do a neat thing. Because we're fault tolerant to losing a zone in that point, we can actually run the MySQL cluster with semi-sync replication. And semi-sync replication is pretty safe, so that lets us turn the write durability down in the MySQLs, and that improves throughput and is nicer on your EBS volumes and probably cheaper. So that's pretty cool. We also have application agnostic sharding, so that's great. And then like 0 downtime resharding, thanks to Vitess. And finally, because of Orchestrator, we have automated impairment handling, which we actually had like, I don't know, a couple months ago at some point. We lost a Kubernetes node to an impairment, and like we did nothing. My team did. We like saw all the notifications in our Slack channel from Orchestrator saying like, oh, responding to dead master on blah, blah, blah. And we were just busy like high-fiving each other. It was awesome. And that means it can happen at night, and I get to sleep through it with no pager. I should have put like a big red line through that thing. That's all we got for you. Want to have a big thanks to Sugu, the main, I don't know, author, architect of Vitess from YouTube, and thanks to KubeCon. Got some links there. Thanks, everybody. I don't know the time, but we probably have time for questions. 35. We should have like 5 minutes for questions.
Yeah.
Yeah.
Are you going to open source your operator?
Nope. Not going to happen. No, it's actually pretty tightly coupled with the rest of HubSpot infrastructure. Yeah.
We would like to point out that there is an open source.
Yeah, there is an
version being
open source
worked on
Vitess operator.
that we have input on.
It's just probably not as good. No, we actually collaborate a little bit on it. But yeah, we can't open source the HubSpot one. Sorry. Yeah.
If I were to use open source operator, what things might I need to care about?
I don't know. I'm not like because I don't use it, right?
Anything that it didn't do, I guess is a better question.
The last I checked, so I'm not super familiar, and probably other people in the room could make a better answer to that. But last I knew, it didn't have a whole lot of like deploy canarying, right? So we have a kind of at this point sophisticated system where like if we want an update across all of our databases, we can designate a few of them as like alpha QoS and roll the database out, roll the change out to that, and then be able to like halt the thing and roll back and stuff like that. And if it proceeds, like keep going and then roll out a little bit faster so we're not, twiddling our thumbs for forever. So last I knew it didn't do that, but.
The other thing to keep in mind is that we started our operator, I believe, before the open source
way
one.
before.
So
Yeah,
we've
way
been
before.
heads down on that.
Yeah, I should say, all this stuff is prod for like a year now. Yeah. Yeah.
Very carefully.
Yeah, very carefully. That's a bit of our infrastructure that we still need to work on. Yeah, we don't have a smooth, like, spray this DDL out across all the shards kind of thing worked out yet. We do have some tools that essentially wrap PT online schema change. We're evaluating another GitHub project right now called Ghost. It's the GitHub online schema change, and yeah, I think we're just gonna replace the backing in our wrapper, like away from PT online schema change onto Ghost, and then yeah, route it so that it like hits all the shards. That'll be like a bypass Vitess kind of operation. Yeah.
Did you look at using console template for the generation of your configuration files?
Not to my knowledge, but that
Yeah,
we're noobs, right? So
Yeah. No, I just
speak for yourself.
yeah, we.
take a look at it, and it's not quite what we
No, I think that's the first I've heard of it. So like we might have just missed it.
The TLDR is that aside from Vault, we're not a very HashiCorp heavy shop. Not for any specific reason, but we're not using console, so we didn't investigate that. But thanks for the heads up.
Yeah.
Just wondering, so you said you had some Helm stuff, and then you went away from that and used an operator. Was there, like, in retrospect, are there things that it seems like they both use the same APIs, right? Wondering. What was appealing about the operator that couldn't be done with the Helm chart?
So essentially, the operator gives us the control of how quickly we roll things out, right? As I understand it, like you give Helm some updated charts or something, or a new release or something, and then it just rolls it out instantly to everything. And like we don't want to do that. And so we could have had like, oh, here's a Helm release for like some alpha QoS things, but yeah, in the end, we didn't. So it's a little bit of a change of perspective, right? Helm and Helm charts is like you have data in a file, and you're managing all your resources by like running commands. An operator, you can like write a piece of code and deploy that piece of code, and then it does stuff. So you can, you have the full.
You're controlling, like, first do the canary deployments,
Yeah.
all those successfully according to certain criteria, then move on to the other.
Yeah.
Of the,
Yeah. So that was, we wanted to move it out of our hands, like in a terminal doing some stuff, into something that we can like reason about for its logic.
Okay, I just want to clarify.
Yeah. No, I mean, you're right. Like morally, they're pretty similar. But yeah, the finer points, like they're.
Another way to think about it is
philosophy.
we absolutely could have implemented this with Helm. It just would have been a layer on top of it, talking to Helm, doing the work. And at that point, it's like, how many moving parts do we want?
Yeah. I think that's probably it on time. We'll be like at the front
We'll be in the
and
hallway.
then in the hallway. Thanks again, everybody.
Thank you.